So what I'm going to put the screws in first. Put the dowels in with the press instead of beating them with a big hammer. Then we'll take the screws out, put the plate on, put Loctite and everything, and put it together for real. The roll pins are going to line everything all up. So these are your split roll pins. So these are going to be put in. So you can either beat them in or press them in. I'd rather press them in than beat them in, because I have a press. Might as well use it, right? Okay, all the parts. Looks like I get something to press on these rollers with. These pins, not rollers. So you need something that's large diameter that will push all the way in the whole surface. So we go over here to my pile of junk. See what we got. Let's see. A bolt. It's been cut down, flush. You can use to push with, see? This has not been shaved off on the other side, like a grade 8 bolt. You can use this to push it on when you want. In this case, I got quite a bit of area right here. I can run something a little bigger. More stability. Something like this. The press to help stabilize it, to keep it from going side to side, and allow you to push straight down better. As long as there's room inside of here for it, like this. There's plenty of room without hitting anything. Looks good. One problem is we got the bolts are over here. So that didn't line up very good. So I can't put this on a press block because these bolt heads are sticking up. So the thing I'll do, I'll just flip it around the other way. We can lay this flat against the block. We can push the pin directly in, and it's going to push this also all the way down at the same time, so everything's pushed together, same direction, tight. I didn't want to go through the aluminum last because the aluminum can shave off aluminum. But these pins have a very large taper in here, chamfer, what are you going to call it? So it helps center things up without destroying things. If this was a sharp edge, it would shave the aluminum right off as it went in. Being it's this way, we're going to be alright. The roll pin is going over slightly. It looks like it's leaning like this right now. So, this is right up against here, which is too far over, so I need to get a little clearance on that. That way when you start pressing on it, the roll pin will come back centered. The pin just does not want to go in straight. See, I just want to roll over different angles. It has a mind of its own. That's why I like dowel pins instead of roll pins. But, so when you beat on with a hammer, you can control things a little bit better, like that. And I still want to press it. You gotta kind of let it find its own happy spot. Once it does, you can push it straight in. There it is, straight in. You gotta keep getting off the press, let pressure up, go back and forth, let the pressure up. Every time you let the pressure up, everything's with center. You push it again. If you keep pushing a pin sideways like that, it'll just break it right off. Like I said, if you go in, it naturally wants to self-center in a hole. If you move, let the pressure up, go over, and come back down. You do it 2 or 3 times, it should square itself up. If you're beating out with a hammer, you can kind of shove it around a little bit. But hammer has got its issues. Good advantages too. With a hammer, you can take out misalignments a lot easier than the press. I didn't want that to go square. Still does not want to go square. To get it started, back up again. Kind of self-centers as you go. So we got pressure on it right now, not much, a little bit. So you just kind of release it a little bit. So you can move that a little bit. That means it's released. You come back and put more pressure on it again. Going about that far, release it. And it goes straight in a little easier. It took about 30% less pressure when I re-squared it up. That means you were binding a little bit when you went in. Okay, so I get the last one right here. Doesn't really matter where the split in the bushing is at. Dowel collapses anyway, so it doesn't really matter. Theoretically, under load, you want to be in a solid part. So that means you want the split to be 180 or 90 degrees from the direction of load. So if you want to do that, you can play around, do those stunts. But something like this, if it gets loose, those dowel pins are not going to keep it from spinning because they will break. Ah, you bastard. So I had it going straight and re-centered it on sideways. Knock it back straight, kind of. Good catch, huh? See that fly out of there? It was not happy at all. It did not want to stay in there. That was a pissed off roll pin. He tried to get away and I captured it. Now the bolts are nice and loose, so that means everything lined up good. If the thread holes are all screwed up, that means there's an offset somewhere in the drill pattern. So this one appears to be good. I mean, somebody used the correct bolt pattern when they drilled it. Okay, that's all good stuff. Go. The Allen for 5/16. Gets used a lot every time I resharpen it, like it's getting ready to be resharpened again. So it starts to get dull on the edge, rounded. Time to knock off 30 so you can get fresh area. This thing started out this long originally, so it's been sharpened a few times. It's getting to be about time to order up another one. Just getting broken in though. I don't know if I want to order another one. Yeah, at some point I'm going to have to. It's getting to be too short. Okay. So you can get more torque with a zip gun than you can by hand. zip gun. Okay, where is my Loctite? Okay, we have a choice of red or blue. I'm going to use red because there's no real reason to be back into here again. So I don't want this to ever come apart. A little bit too much Loctite on there for me. Spread it around a little bit. Oh, don't forget the cover. Cover's made to have lock washers on it. It's stupid. Can't torque a lock washer. A lock washer will split, break in half, and come out in pieces when you start torquing it. This here has a very big hole in it, so the Allen's very thin, so it can move around. You can actually have a pull-through condition. So we need to find a flat washer to go in here to take up the slack. And it can be the thickness of the lock washer pretty easily. So we can go over here and find something that's a decent washer. It's a 5/16, relatively small in diameter. Something like that. Try to get 3 or none. So those ought to work pretty good. So these will take up the distance between the small hole and the big hole. Because that has a big hole in it. So these fit in there. It'll be tighter and do a better job. Oh, the camera ran away. And they make washers with different fitting IDs on them. This is a USS washer, so it's fairly loose. That's the difference in hole size between it and the bolt. An SAE would be a little bit tighter fitment. But these are what I have, so these are what I'm going to use. Now, like a lock washer, when you over torque a flat washer, it just dimples it. Doesn't break. Okay, this is my Ingersoll Rand high output gun. This will put out, used to be 180 foot-pounds. When I bought my new gun here a few months ago, this is 200 foot-pound torque. Now, being a sloppy ass Allen in here, you lose torque, and being a sloppy ass Allen here, you lose torque. So in the real world, you don't get that much torque. But it does torque pretty good though. Yeah. Trying to rip it out of my hands. So that's on there pretty tight. Now you go over all of them, check them again just to make sure. That's hard on your fingers in here. Okay, that's tight. Okay, these ones here, we can't torque them that much. Oh, you dumbass. What'd I forget? Figure it out yet? Got that. Guide. Loctite's still good, you can still use it. Still in there. Still hurt my hands. That time I did it correctly. Alright, so that's all held on there good. We do the other one. And remember, the belt side is the smooth side here, not the sharp edge here. So don't make it nice and smooth with your hand like that. Eat the belt up. Flip it over, goes like this. That way the smooth edge hits the belt and the sharp edge is out here for cutting you. That's the difference. Okay, these are little button heads. Can't torque them very much, they'll round out. This one I think I'll use my little Allen wrench, little L wrench. Here's the bigger one. Guess what they call an L wrench. These are smaller screws, so I'm going to use the blue Loctite. The red would be just about impossible to get these out if you use red. Ooh, that came out quick. Notice I'm not using any flat washers on this one. This has a lot tighter fitting hole here. It's made better. They could have done that with the other one, but they didn't. It goes in hard. Then it frees up. I mean, something's got a bad thread, bad screw. Okay, these are going to torque. Now, an Allen wrench gives you, it's like having a torque wrench built in. When you start to flex, you know you got torque on it. So I don't know if you can see the flex. When you see that whole thing bending, that means you got a lot of torque on it. It has the correct torque. There you go. And this end's getting worn out in here too, because I can feel the screws trying to round off. But it didn't do it yet. A couple more times like that it will. Okay, so now we got our pulley assembly all put together. They could have done that for you now, it'd been easier. And the nut goes right through there still and works. There you go. Okay, that's it for now.